What's up, Precalculus students? This is lesson 53. Our objective for today is, what's the difference between permutations and combinations? And the answer is not one of them has a perm. And how do you calculate the latter? How do you calculate combinations? So first of all, we've been talking about permutations throughout the school year. And that's where we're talking about maybe like trophies on a shelf, where you have 10 trophies. You want to arrange 4 of them on a shelf. How many different ways could you arrange those on there? And we've talked about different variations of that, but you'll remember that this is the formula we use for that. N factorial, if we have 10 trophies, you'd say 10 factorial over n minus r factorial, r is being the number that we want to find out how many we're using. If we go with this, there's 10 trophies, and we're arranging 4 of them, you'd end up with 5,040 different ways that you could arrange 4 trophies on a shelf if you have 10 of them. That's a big number, right? And a lot of times, like with trophies, yes, which order you put them in, it matters. But what if I said, from these 10 people in this room, I'm going to pick 4 of you at random and give all 4 of you the same candy bar. There's not like, you get to pick first, you get to pick first. Doesn't matter, either you're picked or you're not picked, right? So it would make sense, like, how many different options are there? 4,000, 5,400. Well, that doesn't matter. How many of those am I in? And that's all that you want to know. And so what you have to think about is, how many different ways could you arrange those 4 trophies? So think about, there would be 4 in the first position. There'd be 3 to pick from the second position. There'd be 2 to pick from the third position, and then there'd just be 1 left in the fourth position. So if you took that 5,040 and divided it by that 4 times 3 times 2 times 1, you would end up with 210. There's 210 different options for me to pick 4 people at random from 10 people in a room. Seems a little bit more reasonable, right? And it kind of makes sense that if the order doesn't matter, that there's going to be less options, right? If I pick Fred and then John, then John and then Fred, it'd be the same options, right? So the order that I pick them doesn't matter. So that brings us to the formula, if you want to talk about this. Notice it looks pretty much exactly the same as this, right? N factorial over n minus r factorial, except there's one more piece added on to the denominator, which would make this number smaller than that one. Okay, granted, r is not a decimal, but that's beside the point. We're adding on that r factorial because notice there's 4 items in our scenario. There are 4 items. So 4 times 2 times 2 times 1, that's just 4 factorial, which would give us that number there. So let's see if we can do a few of these so you can get started on your homework. Alright, example 53A1. In how many ways can a committee of 5 students be selected from a group of 12 students? So again, since it's just a committee of 5, it's not like a president, a vice president, blah, 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 blah. It's just a committee of 5. I need 5 students from these 12. So I'm going to say this is going to be a combination of 12 taken 5. So it's going to be 12 factorial over 12 minus 5 factorial, 5 factorial. Okay, so this is going to be 12 factorial over, what's 12 minus 5? 7 factorial times 5 factorial. Expanding that, this is going to be 12 times 11 times 10 times 9 times 8 times 7 factorial over 7 factorial times 5 times 4 times 3 times 2 times 1. Let's reduce here those 7 factorials. Let's see here. 5 and 2 reduce to that 10. 4 and 3 reduce to that 12, and that just leaves me with 1 on the bottom. So then this whole thing is going to come out to be 11 times 9 times 8, which is equal to 792. So there's 792 different committees that you could pick from that group of 12. Alright, here is the next one. There are 7 points located on a circle as shown. How many different triangles can be drawn using these points as the vertices? Well, notice they kind of drew one there for us. So that would be triangle, let's say, 1, 5, 6. But that's the exact same triangle as, say, triangle 6, 5, 1, or 1, 6, 5, or 5, 1, 6. Those triangles are all the same. So again, the order that I put those in doesn't matter. So this is going to be a combination. There are 7 points, and I need 3 of them. So it's going to be 7 factorial over 7 minus 3 factorial times 3 factorial. So 7 factorial over 4 factorial times 3 factorial. So simplifying that down, that's going to be 7 times 6 times 5. 4 factorial is reduced, and then I have 3 times 2 times 1. The 6 and the 2 times 3 reduce, so I just end up with 7 times 5. So there are 35 different triangles that I could draw inside that circle. One more here. This is example 53A3. How many different 5-card hands can be dealt from a deck that contains 52 cards? So think about it, if you have 1, 2, 3, the same thing as having 3, 2, 1. So notice here, this is the order doesn't matter, so this is going to be a combination with 52 cards. I'm taking 5 at a time. So this is going to be 52 factorial over 52 minus 5 factorial times 5 factorial. So this is going to be, let's see, 52 factorial over 47 factorial times 5 factorial. 52 times 51 times 50 times 49 times 48. And the 47s would reduce with 47 here. And I ended up with 5 times 4 times 3 times 2 times 1. Let's see here. 5 and this, so 5 and this would become 10. Let's see here. 2 and this would be just 5. 4 and the 48 would be 12. Look, and the 3 would go into that 4 times. So this is going to be 52 times 51 times 5 times 49 times 4, which comes out to be a really big number. Notice it would be really hard to guess what someone has. Alright, your homework is there on page 271. You're going to do 5 through 13 all, then 6 more of your choice. Good luck.